Let's continue our discussion about where and when, examining time and calendar systems. We'll start by reviewing the seasons we discussed last time. Then we will move on to talk about the time of day and calendars. To review, the seasons on Earth are caused only by the tilt of the Earth on its axis. The seasons are not caused by the Earth being closer to the Sun during one point of the year than it is during another point of the year. It is true that the Earth does travel on an elliptical path, approaching the Sun more closely at one point of the year than the other, but this distance is very small. The distance difference, that is very small. And in fact, we are actually closer to the Sun in December, which is winter in the northern hemisphere, than we are in June. The tilt is responsible then for the seasons instead. When we are tilted towards the Sun in the northern hemisphere, the southern hemisphere is necessarily tilted away from the Sun. That is why it is summer for us in the northern hemisphere when we're tilted toward the Sun in June, but it is winter in the southern hemisphere in June. The tilt again has a number of effects on how we experience light from the Sun. When we are tilted towards the Sun, we receive more direct sun rays. The days are also longer. When we are tilted away from the Sun, the beam is more spread out, resulting in less direct sun rays and fewer daylight hours. Let's move on now to the time of day. We can attempt to measure what time it is in a number of different ways. We could talk about the time from sunrise to sunrise. However, this will vary from season to season. As you know from your own experience, sunrise during the winter happens much later than it does during the summer. And the same thing is true of sunset. Another strategy is to try and measure the highest point of the Sun in the sky and call that noon. However, this is subject to inaccuracies because it's difficult to pinpoint the exact moment that the Sun is highest in the sky. And also, if there are cloudy conditions, it may be difficult to see where the Sun is located. Other measures of time are the sidereal day and the solar day. The solar day is the one that we are familiar with. The sidereal day, instead, measures the point from which one star is overhead until it becomes overhead again. The sidereal day is slightly shorter than the solar day. That is because as the Earth is rotating on its axis, as the Earth is spinning on its axis, it is also moving around the Sun. As we know, the number of daylight hours changes as the seasons go by. But how much the number of hours changes depends on where on Earth you are located. The farther north you are located, the more dramatic the changes of daylight hours you will experience going from one season to the next. Near the Arctic Circle, there are times where the sun never sets during the longest days of the year. And conversely, there are times that the sun never rises during the winter part of the year. We are at a more moderate latitude, and so our experiences are different. We do not see such dramatic changes in the number of daylight hours, but they are noticeable. As of this moment, the globe is divided up into what is known as time zones. These are standardized ways of accounting for the time. Time zones were not always used. Prior to the use of time zones, there was a dependence on what is known as local time. Each city and town defined their own time of day. While this was in some ways possibly more accurate, it led to difficulties, particularly with railroad transportation. If a conductor was not careful with his train, an error in accounting for local time as he traveled could result in collisions. This is a note of local history. The Allegheny Observatory in Pittsburgh, Pennsylvania, used to sell the time to the railroads. This is how the Allegheny Observatory paid for most of its expenses at the time. It got very accurate time measurements sidereally from the stars, and then sold the time, the local time, to the railroads to try and avoid collisions. Eventually, however, the time zone standards were adopted, making it so that there was no more need for the Allegheny Observatory to sell their time. If you notice, however, local time zones encompass sometimes very large swaths of the geographical region. So, when the sun rises, even though Maine and Michigan are in the same time zone, the time that the sun rises may be slightly different in those locations. Because in reality, the Earth is spinning. It doesn't just jump an hour when it reaches an arbitrary line that we've put on a map. Let's talk briefly about calendar systems. Throughout time, humans have tried to understand the way the seasons come and go, and to keep track of what day it was throughout the year. Some systems measure time passage by the phases of the moon. The 7-day week that we're familiar with was first used by Babylonians and Sumerians. There's really no significant reason for there to be a 7-day week, aside from tradition. A month is roughly about the same time as a lunar cycle. The word month comes from the word moon and was originally spelled Moonth. But it's not exactly equal to the cycle of a moon. While close, it is not quite the same. This is because we are trying to fit a number of months into a solar calendar. But many calendar systems do maintain a close relationship to the moon and lunar cycles. Our current calendar system hails back to the Julian calendar system, which was a system developed from the Roman calendar. But instead of consisting of 10 months, it consisted of 12. Though some people have difficulty keeping track of which months have 30 days and which have 31, and of course February being different altogether, a simple way that you can keep track of it, if you like, is to use the knuckles of your hand. Start with your left hand and count a knuckle as a month with 31 days. So your knuckle is 31 days. The valley in between your knuckles is 30 days, or 28 days. Therefore, your pinky knuckle is January. The valley in between is February, consisting of 28 or 29 days. The next knuckle for your ring finger is March. The valley in between is April. Your middle finger knuckle is May. The valley in between is June. Your pointer finger knuckle is July. Moving over to your right hand pointer finger knuckle is August. The valley in between is September. Your middle finger knuckle is October. The valley in between is November. And your ring finger knuckle is December, with 31 days. Of course, this is entirely arbitrary, but it does help us keep track if we forget. As you know, February sometimes contains 28 days and sometimes 29 days. That is because there is not an even number of days needed for the Earth to complete an entire orbit. Therefore, we must try and make up for this time by adding a day to the calendar about every 4 years. However, even this is not exactly precise, and so it was decided that centuries that are not divisible by 400 are not leap years. This most recently happened in the year 2000, which, though should have been an every 4th year leap year, was actually not a leap year because it is divisible by 400. BC and AD are also very arbitrary. They attempt to mark the time before the birth of Jesus and after the birth of Jesus. However, if Jesus actually did exist, he is not thought to have been born on the year that this changeover actually occurs. So even for Christians, the year that we have now is somewhat insignificant in relation to the birth of Jesus.